So before I get started, how many of you have heard of Wardley Maps before? Wow, that's about 20–30%. That's quite amazing. How many of you actually use them? Okay, 5–10%. That's still pretty amazing. Okay, so I'm going to talk from here to there and back again. I'm going to talk about situational awareness and how we understand the environment that we're competing in, why it's a good idea not to sail into icebergs and things like that. I'm going to start by talking about the origin of how I got into this particular subject, and then I'm going to talk about maps and why maps matter, and then I'm going to talk about patterns we learn from maps, and then I'm going to use this to explain how we anticipate change, and then finally get onto the subject of AI, because that seems to be a popular topic today. And depending on time, if we have time, I've got a whole bunch of issues about sovereignty and digital sovereignty we can talk about as well. I mean, people often go, but technology isn't political. Unfortunately, it is today, particularly with large language models, but we'll get into that only if you wish to. All right, so origin. So how did I get into this subject of mapping? I was working at this company for Tango, online photo service, 16 different lines of business, had approximately 10 million users across all its services. Very successful, so this is back in 2004, 2005, so just over 20 years ago. Very profitable, but it had a major problem. The major problem was this person, the fat cat in charge. Our fat cat, our CEO, was completely clueless, didn't have any idea what they were doing. They were making stuff up as they went along. Now, I know this for a fact because I was the CEO. I used to come up with these wonderful statements about how our strategy is, customer focused. We will lead an innovative effort in the market through our use of agile techniques and open source. A good friend of mine was Kent Beck, so we'd adopted agile in 1999 before the Agile Manifesto came out. But the problem with this statement was I'd literally pinched it from another company and just changed a few words. That was the level of strategy that I used to do. And then I ended up in a bookshop in Charing Cross, and I was talking to the bookseller and explaining how I'd read all these books on strategy and I had no idea what I was doing. And she asked me, had I ever read Sun Tzu's The Art of War? And I hadn't, so she persuaded me to buy 2 different versions of the book, because she's a good bookseller, and they're all translations. And I was very grateful for this, because in the reading of the second version, I noticed a pattern. So Sun Tzu talked about 5 factors that mattered in competition. 1, have a purpose, a moral imperative. 2, understand the landscape you're competing in. 3, understand the climatic patterns, the heavens, how the landscape is actually changing. Then you get into principles, how you operate, doctrine, and finally you get into gameplay. And at that time, I also came across the word of the mad major, John Boyd. Does anybody know what John Boyd did? No? Yes? OODA loops, perfect. So John Boyd, US Air Force pilot, came up with this idea of OODA loops. The first they're very popular in political circles. The first, particularly with Trump. The first O is to observe the environment. That's what landscape climatic patterns are about. Then you orientate yourself around the space. That's what principles doctrine is about. Then you decide where you're going to act, and then you act. And so this was the strategy cycle. I was really sort of excited by this. It sort of made sense. This is back in early 2005. And I became fascinated by how do you observe the landscape you're competing in. And that's what got me into maps. So I started reading up about maps in military history. One of my favorite battles is this one, the Battle of Thermopylae. So Themistocles, ancient politician, Greek general, had a problem. Persians were invading, about 140,000 odd Persians. Had choices. You could defend around Thebes, defend around Athens. What he decided to do was to block off the Straits of Artemisium, force the Persians along a coastal road into a narrow pass known as Thermopylae. That literally means the hot gates, where a small number of troops could defend against a larger force. So he used the landscape as what we call a force multiplier. Now, there were about 4,000 Greeks in the, because they're independent city-states in the Greek army, including 300 Spartans. Fantastic. That's where we get the story of the 300 from. So I was fascinated by that, and I looked at how I organized myself, how I made decisions in my business, and I used something called a SWOT diagram. Have you ever heard of SWOT diagrams? So I created a SWOT diagram of this battle. SWOT stands for strengths, weaknesses, opportunities, threats. So strengths are a well-trained Spartan army, a high level of motivation to get not to become Persian slaves. Weaknesses, the ephors might stop the Spartans turning up. A truckload of Persians are turning up. Opportunities, we get rid of the Persians, we get rid of the Spartans. We're actually Athenian, we hate the Spartans. And the threats, the Persians get rid of us, and the Oracle reckons a really dodgy film might be produced a few thousand years later. So I've just put these next to each other. I'd ask you the question, what would you use to communicate strategy in battle? Would you use a magic framework like a SWOT diagram, or maybe use a map? What do you think? Map. And what was I using in business? The magic framework, yeah. So at this point, I thought, I need to look at my maps of my business. So I went back into my business and asked everybody to send me all the maps they had, and they sent me loads of them: business process maps, mind maps, systems maps. And this is one. This is the online photo service. And I took this map, various components involved. I took CRM, and I moved it across the screen. That was very exciting. I'm going to do that again. I'm going to move it across the screen. Now, how has the map changed? So exciting. How has it changed? It hasn't. So if I take a geographical map and I say move Australia and put it next to sort of like, next to the UK, how has that map changed? It's completely different. So why hasn't it changed when I move this? Oh, it's because it's not a map, it's a graph. So the one thing all these maps had in common is that none of them were maps, they're all graphs. So to explain the difference, these three diagrams at the top are all graphs, and they're all identical. 3 locations in England, Nottingham, London, Dover, connected by 2 roads, M1, M2. These 3 diagrams at the bottom are all maps, and they're completely different. Now, can you see why they're different? Yeah, it's because they've got a compass. Because the compass does something magical, it gives space meaning. And that's the difference between a graph and a map. In a map, the space has actual meaning. That's why they're good at looking at landscapes, whereas in a graph, it doesn't. All right, so that's all fantastic. So how do you do this? And why does the anchor give meaning? Well, in order to give space the meaning, you need an anchor such as magnetic north, you need position of pieces, this is north, south, east, west of this, and you need consistency of movement. So if I'm going north, I'm going north. If I'm going south, I'm going south. So how do I take my systems graph and turn it into a map? Well, first of all, I have to give it an anchor. So I decided I'd focus on the users, and that could be the business, the consumers, the regulators. So we put those at the top, in this case, business and consumer. Now I need to describe position. Well, fortunately, business has needs and consumers have needs, so we can put that at the top. So the business needs to sell online photo storage. Hopefully the consumers want online photo storage. And then underneath this, there's a whole bunch of components that make that thing happen. So we have a supply chain, And the further we go down the supply chain, the less visible things become. They seem more distant. Now this is a graph. I've got anchor and position. I now need to give it movement. And to do that, I realize that all of these nodes are forms of capital, and we simply ask, how evolved is that capital? We're talking about the genesis of novel and new stuff, custom-built examples, products and rental services, commodity and utility services. And that's how you create a map. So that's what a map looks like. We actually normally say genesis concept, customer emerging, product converging, commodity accepted. But this is a map. If you now move anything in the map, it changes the meaning of the map itself. Does that all make sense? Start with users, understand their needs, understand the supply chain, how evolved the components are. Great. So your first question is, so what? I've listened to this for 5 minutes. 9 minutes. What has this got to do with serverless? Why do I care about this? Right, by simply mapping out environments in UK government, for example, one project alone, we saved £425 million. Simply creating an image. How do you do that? This is an insurance company. This is approximately 2010. This is a process flow. In this insurance company, they're growing. They need more compute. So they would order servers. Servers would go into goods in. They'd modify, mount, and rack them. There was a bottleneck in the modification and racking of servers in their data centers. And so they came up with this entire plan to use robotics. Because there's a bottleneck and we'll use robots and we're going to spend multi-million on robots to get rid of the bottleneck. Very exciting. Now, most organizations are story-led. And when we say story-led, there's a problem because we tell people that great leaders are great storytellers. And that means when you challenge somebody's story, you're actually saying you're not a great leader. So people get really defensive. So they have their entire story already developed, their business case, return on investment calculation, spending multi-million pounds on investing in robotics to get rid of the bottleneck. And I was asked, what do I think? Well, I can't challenge the story. I can't ask them, why are you spending money on robotics? So I said, could we map it? We spent 15 minutes arguing about whether we should map or not. And then 15 minutes later, we created the map. So this is back in, it's 2010. User needs compute order server goods in, modify, mount, rack it. Now, one of the beauties about a map is I can challenge the map by saying I think the map is wrong without challenging the person and their story. So I'll give you a couple of seconds to have a look at that map. Any questions you want to ask about it? Anything which looks odd? Shout out. Why is the rack in custom? That's the question I asked. To which they said, well, we have custom-built racks. So what are the modifications you're making to servers? Well, they don't fit out racks. So we have to take cases off, drill new holes, add new plates in order to get them to fit out racks. And that's why you need robotics, yes. Do you know what somebody then said? Why don't we use standard racks? Yeah, absolutely. So this is extremely common in organizations. They're optimizing process flow and ignoring the fact that things have evolved. At some point in the past, there was no such thing as standard racks. So it made sense to have custom-built racks. But of course, it's 2010. Doesn't make sense now. So that alone, that took us a minute plus 10 seconds. That saved about £5 million by simply not investing in the robotics. Make sense? This stuff is common left, right, and center. All right, so the first pattern you learn is everything evolves. But that's one of many patterns you learn with maps. So when mapping, we tend to do what we call pre-mortem challenge and post-mortem learning. So before we build something, we question what it is we're building, and then afterwards, we use the same maps to look at what we've built, and from this we learn patterns. And if I have a look at this cycle, there are three basic forms of patterns. There's climatic patterns, rules of the game, doctrine principles, and gameplay. And I've already snuck a few basic principles in here for us. Number one, know your users. First thing you do with mapping is identify who the users are. It's amazing how many organizations don't know who their users are. Number two, focus on user needs. So when I wrote the Better for Less paper for UK government, which led to the formation of spend control and helped create something called GDS, I mean, this became a big thing. Again, surprising how few organizations actually understand their user needs. Next one is understand your supply chain. Doesn't matter whether it's physical or software, again, poor understanding. We saw this with things like Brexit, with the Ukraine crisis, with COVID. People don't understand their supply chain. And of course, that's not enough. You've also got to understand what it is that we're looking at, because there's a world of difference between a custom-built rack and a standard rack. So those are some very, very basic principles. And now I'll give you another one. This is HS2, high-speed rail, heavy engineering project. James Finley, former CIO, had a problem. We needed to build HS2 in a virtual world. And the reason for this is it's cheaper to dig up a virtual world and go, whoops, we've got that wrong, than the English countryside. So this is HS2 in a virtual world, and this is about 2012. And normally with government projects, we would do this. We'd break them into bounded context, outsource them in lot contracts, and then have massive cost overruns and failure. So that was the standard process by which we did stuff. And so James thought, well, we'll change that. And he spent Sunday afternoon, he created a map, and he sent me that map and said, how do I manage this environment? Now, this was easy for me because I'd learned this in 2006. I said we used Agile everywhere. That was back in 1999, 2000. Of course, extreme programming everywhere. Of course, by about 2003, we'd learned it doesn't work everywhere. And the reason why it doesn't work everywhere is you've got multiple components. They're all evolving. They're moving from this uncharted space, the uncertain and unknown, becoming more industrialized. And because of that, their characteristics are changing, which is why you have to use multiple different methods. So Agile, extreme programming, in-house, good on the left. Lean, good in the middle. MVP, Scrum, Six Sigma, outsourcing, good on the right-hand side. Because over here, you're all about, reducing the cost of change. Over there, you're about reducing deviation. So simply applying that, this stuff on the left they built in-house using extreme programming. This stuff in the middle, off-the-shelf products. If they were going to build, they used Lean. This stuff on the right-hand side, the outsource, utility, cloud providers. And this project, they used appropriate methods, ended up being delivered way ahead of schedule, way under budget, ended up in front of the Public Accounts Committee. Make sense? Easy. Do you all know that there's no such thing as a one-size-fits-all methodology? Whether it's finance, purchasing, doesn't matter. I mean, you get horror shows like SAFe, Scaled Agile Framework, which attempts to claim it's going to work everywhere. None of them do. Are you all familiar with that? Okay, so very basic. Of course, if you turn up to an Agile conference and say Agile doesn't work everywhere, they of course go burn him heretic. It's no different if you turn up to a Six Sigma conference and say, oh, Six Sigma doesn't work everywhere, burn him heretic. Same with SAFe as well, pretty basic. And then you get into, the climatic rules. These are the rules of the game. They're a different set of patterns, and they're useful for anticipating and understanding change. So this is Compute, roughly, 2005. User needs an application, best coding practice on a runtime, operating system, best architectural practice on compute as a product. First pattern you learned was everything evolves. I thought it was going to be Google which would launch the first utility compute service. Well, SunCloud did in 2000, though, of course, that was a bit of a mistake. So I thought it was going to be Google. Turned out it was Amazon. And with EC2, it was a friend of mine, Ben Black, who proposed it. Chris Pinkham and others, they built it as a standalone service in South Africa. Basically, Jesse, who used to be the master of disaster for Amazon, refused to allow it near any of Amazon's data centers. So you sometimes hear people say, oh, they sold spare capacity, complete gibberish. But the first pattern you learn is everything evolves. The next pattern you learn is past success breeds inertia. Right, who was first with a website, Netflix or Blockbuster? Blockbuster, good. Who was first with video ordering online? Blockbuster, great. Who was first with video streaming experiments? Shout out. Blockbuster, great, fantastic. Who went bankrupt first? Blockbuster. So Blockbuster out-innovated everybody. Okay? Netflix was a DVD mail order company. So why did Netflix succeed and Blockbuster go bankrupt if Blockbuster was out-innovating everyone? It's because they made their money from late fees, which required stores. So they had pre-existing capital. So Blockbuster's problem was it had physical stores. So it had inertia to change. So in the early days of cloud, we saw lots of people have inertia to this change because of pre-existing practices, pre-existing data centers. The next pattern you learn is that as things evolve, you get co-evolution of practice. So compute as a product had something called high MTTR, high mean time to recovery. When it became a utility, it had low MTTR. So the difference is, rather than taking weeks and months to get a machine, we could now get a machine virtually in seconds. And that changed the practices. So in the past, we used to do things like capacity planning, disaster recovery tests. So anybody remember those? Yeah? And we used to do scale up. And of course, as it evolved, we could now distribute systems designed for failure, chaos engines. Really simple. We eventually, Patrick and Andy gave it a term, we called it DevOps. We had all the usual, in the early days of cloud, we had all the consultants run around saying, you can get rid of all your sysadmins, you won't need any of those, usual gibberish. Of course, those who did get rid of them had to then hire them back as more expensive DevOps engineers. So, fairly normal. All right, the next pattern you see is efficiency enables innovation, and then you see that higher order systems create new sources of value and worth. So we got things like Netflix. And this also then leads to this other pattern, which you have no choice over evolution. So as things evolve, they become more efficient. This increases the speed through new practices, creates new value, new needs built on top. And if you're competing against others and they have efficiency, speed, and new value, they create pressure on you to adapt. And as more adapt, everybody has to change. So with cloud, it was never a question of if, it was only a question of when. Really basic stuff. So back in 2008, I used to run strategy for a company called Canonical. Have you heard of Canonical? Yeah? So we used a map to identify where to attack, slightly more complex than this map. We were up against Microsoft and Red Hat. Have you heard of Microsoft and Red Hat? Okay, we were 3% of the operating system market. It cost me $500,000, took us 18 months. We took... So attacking those spaces, also avoiding where not to invest. That's something I forgot to mention. It's really important not to invest behind the inertia barriers when things are changing. So attacking where we needed to invest, we took 70% of all cloud computing with Ubuntu. Have you heard of Ubuntu? Was anybody involved in cloud? 2008, 2010? Saw that it was all Microsoft, Red Hat, and suddenly Ubuntu owned the entire market. Does anybody remember that? Anybody in cloud in those days? No? Some of you must have, yeah? Do you remember it was Ubuntu just dominated? Yay! You were mapped, okay? So the point about this is we didn't have the billions of Red Hat and Microsoft and the tens of thousands of engineers, and we were Ubuntu. But we knew where we could attack. So it's a bit like the Battle of Thermopylae and the 300 Spartans. If you can use the landscape as a force multiplier, which is how we went from 2008, almost nothing, 2010, we own cloud. Really simple. All right, so by about 2010, these new emerging practices have evolved. We gave them a new name. Andy and Patrick called them DevOps. Everybody got very excited by that. 2014, the runtime shifted, became more of a utility with Lambda and serverless. And guess what? The same things happened. People had inertia to the change. We got a creation of new practices because of the change of characteristics and new things built on top. And eventually, those practices got a new name. We called it FinOps. So this is event-driven architectures, capital flow in applications, so billing per function, all the stuff I don't need to tell you because you're here at serverless anyway, so you know this stuff. All right, so all pretty basic. So that's where you would invest in 2016. And of course, the place you would avoid now is all this stuff stuck behind inertia barriers, including cloud and DevOps. So I used to go to conferences in 2016 and tell people that DevOps was the new legacy, to which they would go, burn him, heretic. But yes, it was. We were moving up the stack, fairly normal. And so Dave wrote a wonderful book, The Flywheel Effect. I recommend you read that. And then we get into the strategies. So this is how you manipulate the market to your favor. So there's about 30 common economic patterns useful for anticipation. There's 40 basic principles of doctrine, things like focusing on user and user needs, useful for organizing yourself. There's about 100 different forms of gameplay. It's very easy to manipulate the market to your favor, but we don't have time, so I won't be going through those. What I will be talking about, however, is AI. Oh. So back in 2016, this is roughly what the market looked like. I'm going to ignore most of it and stretch it out because I'm not going to talk about compute and Kubernetes and all that stuff, which is like down there somewhere. I don't care about that. I'm going to start from the point of view of serverless and FinOps and coding environments because that's the only thing that makes sense. Back then, we saw that machine cognition was rapidly evolving. So we knew it was going to become more of a utility. We didn't know quite what the form was going to be. So this was back in 2018. We knew we'd get new practices appearing on top of this, new needs, but it wasn't really that exciting, except for the fact that when it combined with some of these ideas in FinOps. So we came up with this term, which was called conversational programming environments. And this was based upon the work of Nicholas Negroponte and Jonna Freeman back in the 1970s. So the process of design can be viewed as a conversation occurring between multiple designers. And so what was going to change was one of the designers was going to be a machine. So based upon this presentation, a good friend of mine, Alexander, went and built this and presented it at AWS reInvent in 2018. So this was an AI system built on Lambda, which you had a conversation with. And actually, you could have two different forms. You could either do it through text or you could do it through verbal. And so you had a conversation with this AI, and it built you a serverless app as a result of it. So that was 2018. Some really interesting stuff going on there. So we roll forward to 2024. Nothing much has changed, except for we now have terms for things. The thing at the bottom, the industrialized machine cognition, we call it large language models, large multimodal models, great. And the new practices, we still can't work out what we're going to call it. It varies from co-pilots to prompt engineering to chop to vibe to whatever, but it's all conversational programming. The thing I will note is it's still very much like all these practices, like the early days of DevOps, it's still emerging, so we're still working out exactly what those practices are. I know people are writing books on this stuff and everything else. It's all very exciting, but we're still learning. Okay, so what's fundamentally changing? A couple of things. If we look at coding environments and co-pilots, our tool sets are changing. In fact, I would argue they are not changing far enough. Why? I like soup. So I'm going to explain a physical example and then bring it into the software world. So I like soup, and when I make soup, I use a blender because I like my soup to be fairly smooth. So here's a blender, it's a tool. Now, if you ask me to build a deep shaft mine, I'm not going to use a blender to build a deep shaft mine. I mean, because that just wouldn't make sense. So in physical engineering, I will use a mining machine. That will make me happy, rather than trying to use a kitchen blender. Now, software, in terms of the applications we build, are all symbolic instructions. And the tools are all symbolic instructions. And for some reason, despite the applications being different, i.e. an electronic healthcare record system is not the same context as an online gambling site, despite the fact the context of being very different, we try to use the same tool sets all the time. We even talk about it. Oh, we should have standard tools everywhere. That's a bit like saying we should build mining with kitchen blenders. Software engineering is the only engineering discipline I know of that tries to use standard tool sets. Great for tool vendors, sucks for software engineers. Now, we do it because they tell us that building tools is hard. Well, software vendors are going to tell you, if they're selling you a tool set, that building tools are hard because it's in their interest to do so. And so what they're now telling you is, well, you're not very good with kitchen blenders in mining, so what you want to use is robots with kitchen blenders to do mining. That's what's going on with AI today. Except for one place, tests. Tests are very small tools. They have an input, output, do a transformation. That's what a test does. If you're writing or building a software project, and I'm your manager, and I turn up and say, hey, I've spent a load of money buying the Acme 100,000 test suite that we should run against our application, what would you think? Does that make sense? Why? It doesn't make sense because you'd look at me thinking you're mad because we build tests for our context, for our system. Which is why we build tests for our context, our system. But tests are just small tools. The rest of the tool set, we happily go and, we'll use Cursor, we'll use whatever. We try and use standard tools all over the place. Big problem. So there is a change going on to use something like Glamorous Toolkit, moldable development. To give you an idea of performance change, I've seen results of not 5x or 10x improvement in using contextual tools, but 600x. So all the stories I keep on hearing about how fantastic AI is, I think we're nowhere near the limit of capacity, the skill of human beings to actually develop systems. And I think we've been sold a pig in a poke. So the tools are changing. The languages are changing. We're going from deterministic code to non-deterministic prompts, so conversational language. Prompts are a form of coding, particularly if they've got memory, they're Turing complete, but they are non-deterministic. So your prompts are not commands, they're wishes, they're intents. Okay? And our medium is changing. We're going from code as text to much more code, including other forms of symbolic instructions, such as images. Now, that's a big deal. On the right-hand side is a map of coherent city transport. You don't have to read the map. On the left-hand side is the code that generates the map. Now, when I have a discussion about the map, I'm talking about objects, relationship, and the context it exists within. When I'm talking about the code, I'm talking about rules, syntax, and style. So it's the same problem, two different conversations, depending upon the medium. How many of you work in a software engineering department? Hands up. Right, how many have got whiteboards in your engineering departments? Hand up. Okay, so exactly the same thing occurs in every engineering department. We have two conversations that go on. One is on the whiteboard, objects, relationship, context. One is on the screen, objects, relationship, well, syntax, style, and rules. Okay, same problem, two different conversations because of the medium. Now, when we talk about AI, we're thinking that AI replaces the coder. Or if you're Eric Schmidt, there will be no coders left by the end of the year or whatever. I mean, God Christ. So the idea is we'll come up with this design right here. We'll hand it over to a large language model, maybe, with a couple of other agents around it as well, using tools. And hey, presto, it will write all our code. Okay? The problem with this is not what architecture looks like. This is a hand-drawn diagram, a statement of belief. This is what actual architecture looks like. So this is a pretty simple system, every function, every node, and the interconnections between the functions and every object on the system. The reality is the architecture is the code, or the code is the architecture. Which means this person here, writing the code, is the real architect in decision-making. This is just a statement of wishes, intents, and beliefs. How many of you have seen an architectural diagram? Hands up. Right, how many of you seen an architectural diagram which actually represented the system in production? No one. Good. These are purely statements of belief. They are not real. This is where the real decisions are made. So one of the big decisions going forward is how much do you value a human to be involved in that decision? Because there's a world of difference between software engineering plus AI. So this is where we get an AI to write some of the code, and a human then looks at it and reviews the code. So that's humans evolved. And the world of vibe coding, which is I come up with a bunch of wishes, intents, beliefs, and the system codes something for me, but it makes all the decisions, and what it codes may or may not represent what my intents or beliefs are. Has anybody done any actual vibe coding without looking at the code? Anybody here? A few of you, without looking at the code. Yes? How do you find the experience? Challenging. It's not really coding, is it? It's more wrangling. You try and force, you're trying to get the system to. I had one system, I asked it to create a testing engine for me. So it created a testing engine, great. And every time I write a function, I'd ask it to add new tests for new functions, so it did that. And over time, I started to feel there was something wrong. And it got so bad that eventually I broke my rule and looked at the code. And so it hadn't actually built me a testing engine. It built me a simulation of a testing engine. So what it was doing was every time I changed the code and updated a version number, it was randomly calculating based upon the version number whether I should have an error and what that error message should look like. And every time it was building me a test for a function, it was basically say, this error should occur with this frequency, and this is what the message should look like, roughly. And so I was getting these error logs going, oh my gosh, copy that, but can you fix this? Yes, I can fix that. And it would fix it by upgrading the version number. And they would magically all disappear. It was like, God, this stuff is brilliant. But it's just hilarious. So where does it make sense? Well, look. If I go back to a map, you're going to outsource some stuff. Hopefully, you're not going to try and build your own power. You're not going to build your own compute. Hopefully, you're not going to build your own runtime. You're going to use a serverless environment. Excellent. But you are going to build some stuff. So some of this stuff, you're going to vibe code. As in, we'll prototype it with an AI, and we won't bother to look at the code, and we're just like, but we're not going to put really into production. It's more for exploring a space. And the rest of this stuff, we're going to use a mixture of software engineering plus AI. And of course, the boundaries of this stuff will change as we get more trustworthy, more familiar, we build capabilities. I mean, I will hear people say, oh, but you can do all the testing and reviews with agents, and agents are basically LLMs with tools, and that's great, but they hallucinate just as much as the original systems. In fact, everything large language models do is hallucination. It's just that sometimes the hallucinations match reality. Okay. You are not going to get, however, vibe coding of, nuclear safety systems anytime soon. I mean, eventually, we may build those practices, but it's going to take time. One other thing to watch with is medium, language, and tools are all changing. And one of the real dangers is that controls how we reason about the world around us. So if you think of tools, think of printing press, medium, paper, language, written word. If you give all of that control to a small group of people, they control literally how you reason about the world around you. It's very dangerous. A bit like, I don't know, pick a group of people you hate in history, any group. Say the English. All right. Okay, let's say, but yeah. If we control, you come up with, you want new words, we say, oh, you can't have that word. These are the only words you're allowed to use. We want to publish a paper. No, you can't do that. Only publish on our paper things we like. We want to use a printing press. Oh, not for any of that stuff, I mean, it controls how you reason, which is why most of these large language models are basically creating a new theocracy. I mean, trust us, we have guardrails. We need all this stuff to be open sourced, all the symbolic instructions, and that means all of it, not just the code and the model, but also the training data as well. That's the only really effective way of combating the creation of a new theocracy. So I started off with the origin, how I got into the subject of situational awareness. I talked about maps and why maps matter. Then I talked about patterns and how you use those for identifying different methods to use, how things evolve. So we talked about change and how we got to cloud and to serverless and eventually onto AI and some of the interesting issues around the change of tools, the change of language, and the change of medium. If I'm going to ask you to go away with some lessons, it would be, please, number one, try and observe your landscape. It seems ridiculous, it's 2025, but the number of companies who don't understand their users, user needs, supply chain, how evolved those components are, is extremely common, and it doesn't matter whether I'm thinking about using cloud or serverless plus AI. Understanding that landscape is important. My name's Simon Wardley. You can find me here. You can find me on LinkedIn. I work with various different groups. Think does something called Glamorous Toolkit, which is in the moldable space. eSynergy does a lot of stuff about outcomes and values. I do have a little bit of stuff on sovereignty. I notice I've got 6 minutes left. Or 5 minutes left. Do you want me to show you the horror of digital sovereignty, or do you have a question? It's up to you. Where do you want to go? Horror. You want more horror? Okay. So when it comes to, has anybody heard anybody talking about digital sovereignty? Yes, right. Okay, fine. So, I said organizations are mostly run by stories and people don't actually understand the landscape they're competing in? Yeah? Well, we compete over many different landscapes. So when we talk about competition, competition is the act of striving to something with others. And there's three basic forms: conflict, fighting others; cooperation, helping others; collaboration, laboring with others. They're all part of competition. I know there's a group of people who like to pretend that competition is just conflict. Well, why don't you just use the word conflict then? But they like to pretend it is the same, because then they can write books about that you have collaborative competition or something along those lines. They're all the same. They're all part of competition. It's like that. Oh, who's that dreadful book? It's all about resilience. They redefined resilience so they could create a new word, anti-fragile or something awful. But anyway, conflict, cooperation, collaboration, all part of competition. So when we look at sovereignty, we compete over many landscapes. One is territorial, the environmental landscape. And others are the economic, technological, social, and political. And they're all landscapes. So when we talk about territorial, here's our landscape, our border, here's our society. Cross our border, we conflict with you, cooperate, collaborate outside. Pretty basic. Now, when it comes to digital, technological, and economic spaces, we have no maps. So we're back into story form. So we love to talk about, we can't even define where our borders are. So this is the automotive industry. There's a graph, a bunch of things connected. What does digital sovereignty mean here? I don't know, randomly pick stuff, let's say data. It'd be like you could have one of these of the territory with trees and hills and rivers, and you say territorial sovereignty is all about protecting trees or something, equally nonsense. So this is the DVLA back in 2015. We created a map of the automotive industry. We rolled it forward to 2025, so most of the industry is becoming more commodity-like. Particularly interesting looking at the actions of China as well. China's a great game player, incredible, actually. How are the automotive companies going to react? Well, the first was we anticipated they would do digital subscription models. And sure enough, 2018, BMW, I think it was, came out with, digital subscription to have a heated seat, a warm bum, something along those lines. Very exciting, very innovative of them. The other one we thought they'd probably do is route management. So route management is, if you imagine in a world of self-driving cars, there's the cars on the road. These are all bronze members. Here's gold member up here. And of course, what will all the other self-driving cars do? They will get out of the way so that gold member can get to wherever they're going to more quickly. And they'll do this because companies are a bunch of idiots. And the reason why I say that is because what we've done is now embed social inequality into transportation system. If we have a flood, then all the poor people are standing by the side of the road while all the rich people are getting out. The next day we have pitchforks revolution because people get very angry about that sort of stuff. I mean, that's the thing about government. It has to, the market just does the most stupid things. I mean, government is there to stop the worst excesses of the market. I mean, God, the market back in the 18th century thought slavery was a good idea, but there we are. So if you have a map like this, one of the things you think about is those users are members of a society, those society has values, those values are embedded in simulation models which train our intelligent agents. So if you're going to talk about digital sovereignty, you're going to consider what those values are. So to give an example, do you know what the trolley problem is? Right. Say a car coming along, you've got a choice. Do you kill one person or 5 people? Hard choice. Which one do you kill? Okay, probably the one person. What if that one person is a gold member and the 5 people are only bronze members? Who do you kill then? Well, hopefully, still the one person. But it depends on what sort of society you live in. Okay? So those values are what's going to be embedded in these simulation models. So when we talk about digital sovereignty, again, it's the same thing with maps. Where are our borders? Where do we need to protect? Where are we willing to collaborate? Where can we cooperate with others? Unfortunately, as I said, we don't have any maps, radar, situation rooms, unless you're in China. We're pretty hopeless at this stuff, so it's all sort of degenerated to story form. So there we are. So I started off with the origin, situational awareness, patterns change, went to AI, little sort of journey into sovereignty. All I will say to you is observe the landscape that you're operating in. Think about where human decision-making matters. Think about the tools that you're using. And if you really wish to, think about some of these sovereignty issues, what it is that we actually need to protect in this space. Enjoy your conference, have fun, and thank you very much.